Hello again. We're going to talk about naming in this section. And naming is really important. Chemistry is like taking a foreign language in math, is kind of the way I think about it. We have so many things, vocabulary and things we need to learn. So it's just like learning and translating things into a different language. So we use math as a language in chemistry, and then we have a lot of terms that you need to know in chemistry. So let's move to learning how to name ions in this section. So remember, the group number helps you figure out the ion charges. So we have to use a periodic table to figure out a lot of these things. So monatomic ions are ions that have one atom and they have a charge to them. So this is all the group A metals and nonmetals are what we're talking about on the periodic table. So you might want to grab a periodic table to look at. So they contain one atom, and they either have a positive or a negative charge, and it's based on their valence electrons. So we have to know their group number. So elements 1 through 3A lose electrons, and they form cations with positive charges. And we just call them like sodium ion. Those guys, we just change their name to their metal name and their ion. So group 1As are going to have a +1 charge, and 2As are going to have +2, and 3As are going to have +3. They're all going to be positive cations. And then the elements on the right side, the anions, are going to be, we're going to figure out their charge based on the octet, and then we're going to change their name to ide. So for example, 5A are going to have a -3 charge. Oxygen's going to have a -2 charge. Group 7As are going to have a -1 charge. So those are all the A's. And then metals down here, these transition metals can have different charges, and these are ones we're going to have to tell you what the charge is. So you don't have to memorize this part, just the A kind of people, just the A elements, not the B's. So here's some examples of charges, and they're based on their groups. So take a look and see the pattern. The 1 through 3 are positive, and then 5 through 7 are negative. So cations on the left, anions on the right. And then the transition metals are the ones in the middle, and they can have more than one oxidation number. So, for example, these are different transition metals that are in the center of the periodic table, and these guys can have variable charge numbers. So we have to tell you what those charges are when we give you the name. And here's some transition metals have really cool colors. So there's two ways to name those the B's in the center of the periodic table. They're called transition metals. We can use something called Stoch system, or we can use the classical method. And I'm going to favor the Stoch system because it's the way it's the newer way to do it. And we're going to use Roman numerals to tell the charge of the positive transition metal ion numbers, their charges. And we're going to not use the old way. So we're going to look at the Stoch system. This is the ones we care about. So you notice they have Roman numerals here, and those Roman numerals are telling you the charge. So lead 4+ is going to be, its name's going to be lead Roman numeral 4 ion. This is the old way, and we don't care about that. That's old school. You might see that in books and old stuff. But we want to label and name everything this way because this makes more sense. It's easier to do anyway because it just has numbers. So when we look at these ions, potassium is group 1, so it's going to be +1. Iodine is going to turn into iodide ion. Sulfur is going to turn into sulfide ion. And then lead 4+ is going to be called lead Roman numeral 4. It's cation. So positives cations, negatives anions. So what about if we have those polyatomics? I've been asking you to memorize those, so I need you guys to know those. And so here's some polyatomics, and they have a unique name. So NH4+ is called ammonium. Nitrate is NO3-1. So these are things we have to memorize because we use them a lot. These are covalently bonded together, but the overall ion has a charge to it. The overall structure has a charge. And these are called polyatomics. And they have names of ite or ate, depending on how much oxygen is part of them. So these are the ones I need you to memorize. So like I said, make some note cards and start memorizing them, flashcards, and memorize them, or go on an app and find an app that will help you memorize those. They're really important. We need to use them a lot. So sodium hydrogen carbonate is something we use to relieve stomach. And so if I just gave you the name, I need you to remember that hydrogen carbonate looks like that. So if you didn't know that, you wouldn't be able to give me the formula. So we need to start learning those things. These ions are in your blood. So they're all very important ions. Here's some fertilizer ions, phosphates. So let's see how much you remember. So, what do you know about groups 1A, 2A, 3A? So their charge is based on their group number. Let's try the next one. Which ones are positively charged? Polyatomics. So there's only one, so that makes it easy. This is the only one with a positive charge. Ammonium, NH4+. Is ammonium. It's the only one with a positive charge. Last question. What do ites and ates have? So ites and ates have oxygen and they're polyatomic anions, and then we're going to have to start memorizing this. So start memorizing those, make some flashcards, and it'll help you a lot in this class. I'll talk to you soon. Have a great day.